and we'll go straight to the slides. So we're going to learn a programming language today. I'm excited. Usually, I like to give my classes. I like to do my classes a bit differently on Mondays and Wednesdays. On Mondays are going to be like our ethical issues / philosophy lectures, and then on Wednesdays will be our programming lectures. So that's how I'm going to try to keep it in this class. Some holidays might ruin that, but that is the idea. So we're going to learn about Scratch. It is a programming language. So today is a programming lecture. All right, so I would like you to follow along. I'll show you where to go. Ask tons of questions, please. I will be here to help you as much as humanly possible. Okay? So yeah, let's get started with Scratch. But before we get there, I need to talk to you about like what is programming, what are programs, so that we're all on the same page. So let's do that first. All right? What is a program? What is an algorithm? What are these words? So a program is essentially a collection of little algorithms that perform some task. Okay, so an algorithm, it's really just a recipe. It's a sequence of steps to achieve some goal that we have, okay, that we care about doing. So if you have modified a recipe to make it tastier for you, you have essentially programmed. Okay, that's pretty cool. So here's my silly example that I like to give at the very start of CSCI 1 and CSCI 40. I would like you to get practice programming. So could somebody tell me the algorithm to make a peanut butter and jelly sandwich? Let's pretend like I bumped my head and I have amnesia. I have forgotten how to make peanut butter and jelly. What's the algorithm? Yeah.
Take 2 pieces of bread out of a bag of bread.
Yes.
On a plate.
Mm-hmm.
Spread peanut butter and jelly on the bread. Basically put them together.
Very nice.
Put it in your mouth and eat it.
That's the most important part, right? Any other algorithms for peanut butter and jelly, or did that sound good enough?
Yes. You probably want to apply the peanut butter and jelly on.
Yes, very important. Very important. So I think maybe you guys have watched my CSCI 40 lecture or something. You know where I'm going with this. If I were in this class, what I would have said, here's my algorithm. It's just like, all right, give me bread and then put some peanut butter on the bread and put some jelly on the bread. Voila, you've got peanut butter and jelly, right? That's probably what I would have said. And I'm going to pretend that I'm a computer running that program, okay? So it's like, all right, take some bread. Here I am, the computer, getting the bag of bread out. My best 3-dimensional bread bag drawing. Whee! Here's the little slices of bread in the bag. So you're like, all right, to make peanut butter and jelly, get some bread and put some peanut butter on the bread and put some jelly on the bread. Right? So here is the peanut butter jar. I, as a computer, will put that on the bag of bread. Yeah, you told me to put the peanut butter on the bread. I did it. All right, put the jelly on the bread too. So I'll just place the jelly jar on top of the bag of bread as well. So that's me, the computer, running that program. And it feels good about itself. It's like, voila, I have made you your peanut butter and jelly. That's exactly what you wanted, right? Of course not. Right? We wanted something we could eat. So the issue there is computers are really smart, but they're also really dumb. They can do a lot of cool stuff, but you have to talk to the computer in a way that it understands and that is unambiguous. All right. So as a computer, I would follow your instructions to the letter. Exactly what you say. Put peanut butter and jelly on bread. Well, I did that. What more could you have wanted, right? So the goal of this class is to teach you how to essentially talk down to the computer so that you can think in a way that is similar to what it understands. It's called computational thinking. So I'm going to teach you how to think computationally in the programming lectures for this class, and that will help you write your programs correctly. All right, you'll have to end up using smaller steps, little bite-sized pieces that the computer can understand, and you'll also end up being very, very specific about what you want. So like some of these students have told me earlier today, the correct way to program the peanut butter and jelly sandwich would be something like, all right, get out a plate, take out the bag of bread from the pantry, open it up, get 2 slices of bread, put them on the plate. Right? Get a knife out of the drawer, open up the peanut butter jar, spread some peanut butter onto the knife, spread that onto one of the slices of bread. Do the same thing for the jelly. Put them together so that the peanut butter and jelly are touching each other, otherwise that's the wrong way. Right? Something like that. That would be the level at which you have to talk to the computer. Does that make sense to us? So that's how we're going to program. Okay, that's the goal. And that's a program SAS algorithm. Are there any questions about any of that? All right. So we are going to be learning eventually Python, which maybe you've heard before. The first language that I will use to get us ready for Python is called Scratch. All right. It is a graphical programming language, but it's still a real programming language, and you can write real programs in it. So don't feel like it's any lesser. Here's what Scratch looks like. You're going to be essentially like building two-dimensional Lego towers, and those are your programs. It's pretty cool. So Scratch is made up of a bunch of blocks that you can drag out onto your program window, and each block does a different thing. Like you drag out this block, and that block performs some operation, like it adds some numbers or it makes some animation happen. And then you can put another block underneath that, and it just fits in ever so perfectly, and that does some other operation right after that one. And then you can put in a third block underneath that, and then that'll do some different operation 3. Okay? And the idea is once you put all these together, that's your program. You can run it, and it performs these operations in order from top to bottom. Okay, that's how the program is going to work. So all of these blocks that each do different things will be run in order. Okay? Another word for run is execute. It's a weird metaphor. It's not like somebody's killing your program, but these blocks will execute in order, we say. Okay, and execute is just a fancy computer science term for the word run. It's going to run those blocks, whatever they do, in order. That is Scratch. Okay, so let me take you to Scratch. It is scratch.mit.edu. If you go there, it's that one. Sorry if that's small. Go back to this one, scratch.mit.edu. And you can just probably search Google for Scratch MIT, and it'll take you there. But please follow along. I would encourage you to go there and definitely practice what I do today if you can't do it in time with me. But I'd really like you to follow along if you can. All right, scratch.mit.edu. I'll also go to this Wikipedia page. It's kind of fun. So once you get there, you'll click Start Creating, and that creates a brand new program for you. And so once you load Scratch, you are plopped into, close that, you're plopped into a window with a bunch of things. And so let me explain all the things. So on the, I think that's I don't know, I guess I have to do it in that size. Sorry, it's a little small, but you'll have it open too, right? So on the left side, you have a bunch of blocks you can drag down, and there's a ton of them, and they do different things. And you can drag them into the middle. Middle is your program. That's where things happen. You can line up your blocks and you create a program in order in that way. And then your program runs. And it affects this window over here. That's the Scratch cat. He is the default thing that appears in any program, but you can put more stuff over here. But the idea is you write programs that manipulate the little people who are in the window over here in your program window. They're called sprites. So the Scratch cat is a sprite, and he's like the mascot of Scratch. He has his own Wikipedia page and his own lore. Yeah. And you can use any pronoun you want with the Scratch cat. Non-binary. So that is the idea. So that's the Scratch cat. He appears in every program window. You can get rid of him if you want. You can add new sprites. You can also add backdrops. It all looks very cool, but we're gonna keep it pretty simple today. Okay, so you got on the left side the blocks that you can use to build your program. In the middle is where your program lives, and then on the right is where the program that you write runs and affects the world in this window. Okay, that's the idea. So the very first program that I want to teach you is called the Hello World program. It's just customary when you learn a new language to write a program that pretends it's sentient and can say to you, "Hello world, I exist. You made me say this." Okay, so I'm going to make a very simple program that is going to have the Scratch cat announce to us, "Hello, hello world." That's just the standard default thing to do when you learn a language. So I'm forced to do it with you. Okay, it's just tradition. So let's find the block that allows the Scratch cat to say something. Okay, and he's right now called Sprite 1. We can call him Scratch cat if you want. It doesn't really matter, but that's the idea. So All right, does anybody see, did anybody scroll down and see if they found a block that sounds like it'll make the Scratch Cat talk? Anybody notice it? Which one? No, we don't want to make, this will actually make sounds. It'll say meow. No, we don't want that. We don't want him to speak. Yeah, it's above. It's say. It's the say block. So it can either say hello or say hello for for a certain number of seconds. Those are all interchangeable. So let's let's do this block. Let's have the say hello, and I'll zoom in here so you can see it a little better. Say something for 2 seconds, for 5 seconds. You can change all that. And we want him to say hello world exactly, of course. And that's the block. So it's a 1-block program, very easy. And to run it, to execute it, if you just click the block, it'll start running in the program window. And there the Scratch Cat goes. He says hello world for 2 seconds, and then the text bubble gets rid of itself. So you can keep re-clicking it to replay the program if you want. But that's hello world. Are there any questions about that? That's a program. And you can put those together, like hello world for 2 seconds, and then hello right after that, right? It goes in order. So first you'll say hello world if you click it, and then 2 seconds later you'll say just hello. I think you can see what's happening there, right? So that is, that's probably the simplest Scratch program. Are there any questions about that? Things can get much fancier, I promise. So let's see here. What else do I want to do? I just want to kind of give you a feel for what's on the right-hand side. So you can have as many, you can have a ton of sprites. We just have the Scratch Cat right now by default. But if you move them around, you'll notice that there's a coordinate system underneath everything. Like in the middle is 0, 0-ish. And then over here is -x, over here is +x, +y, -y. If you move him, you'll notice that his coordinates change. And we will eventually manipulate the Scratch Cat's coordinates to cause animation. Okay, that's the goal eventually. You can change the size of the Scratch Cat. He's right now 100%. You can make him 200%, giant cat. The text bubbles don't get any bigger though. He's also, like, you can show or hide him with this little picture of an eye. And then also there's a direction to the cat, so you can manipulate his direction. I guess the default angle is facing to the right, which is 90. 0 is straight up, I guess. But you can also manipulate this programmatically. That's eventually going to be our goal. So that's going to make him like twirl and stuff. So that'll be cool. Wait, so back to 90 with you, Mr. Scratch Cat. Oops, didn't want to do that. 90, please, for your direction. There you go. Okay, so that's the Scratch Cat. This is kind of cheating for a program. I'd like to make it a bit more of a real program. So in Scratch, usually you don't just click the blocks to run them. It's good for testing purposes, but that's not the normal way to start a program usually. We would like to be able to start our programs with things called events. In Scratch, you need something called an event to start the program, because clicking on the block is just testing. It's kind of cheating. So what we'd like to do instead is, let's have this green flag up here, start our program. When we click it, let's have that run our entire program to completion. That's going to be our goal. So the event that takes place is us clicking the flag. And that'll start the program. And there's a nice event in our events block section that starts with when the green flag gets clicked. If I put that at the top, that is going to start my program. So when the green flag gets clicked, all the stuff below that event will get run. Does that make sense? And notice it's kind of obvious from the way that the block looks as well that nothing can go above it. It's what starts the program. You see that? Only things can lock in below it. Isn't that beautiful? So when the green flag gets clicked, do all this stuff. That's a better way to start the program. Okay? Hello world, yay. And then hello for 2 seconds. Green flag gets clicked, it runs everything below it. Okay? We good with all that? Please shout out if you have any questions about anything. All right, so that's when the green flag gets clicked, do all that. The other thing that I want to tell you, so yeah, events start programs. They start your computation. There's also nice things that are just for you, the program. They don't do anything in the code. They don't manipulate the program. They're just for you. They're called comments. They don't get run. They don't get executed. It's just for you. All right? So let me find, I think it's just you right-click on a block and you say Add Comment. And that leaves a little sticky note for yourself. Okay, you can put anything here. It's not code. It's just to remind you when you come and open this program a week from now what you were doing. It's kind of obvious what this program does, but you can imagine how useful these can be once you make larger programs. All right, so it's like print hello world for 2 seconds, something like that. So you can leave yourself little sticky notes, and those are called comments. You can right-click, add comment. 2 seconds later, say hello. Sweet, because it takes 2 seconds to say the first hello world, right? Or maybe we can have him say goodbye, because that's the end of the program. All right, you can change it up. You can make it last shorter, last longer, but that's the program. All right, we still good with all that? So I'm going to give you all this. I'm going to save it. If you go to File, you can save it to your computer. You can also load it later. So I'll save this so that I can give it to you later. But that's our first little program. So we're ready to make more fancy ones now. Okay. So my next example is going to involve animation. It's going to be, let's have the Scratch Cat feel hungry, and he'll get a banana out of the fridge because apparently he likes to eat bananas. Okay. So let me talk to you a little bit about that. Let's set the scene, and then I'll walk you through the algorithm that we can come up with to make it happen. So we like the Scratch Cat. Let's name him Scratch Cat, just out of respect. And I went to File New to make a brand new program. Okay. Let us add a backdrop. I think there's a refrigerator or a kitchen backdrop. Fridge. There's a refrigerator backdrop, and so now the background is a fridge. Cool. That was in the backdrops button. Plus, choose a backdrop. We also need some bananas. Bananas are sprites, so choose a sprite. You can scroll down, but it's just right there. Yay, here are the bananas. I'll put them in the fridge. Okay? So that's going to be the start of our program. Let's see here. And so now I would like to tell you about the differences that you can make happen in this window. So motion is going to be very important for this program, right? Here's this move 10 steps block. If I click it, it moves the Scratch Cat. The first thing that I want to tell you is each sprite gets its own program. So notice, if I click on the Scratch Cat right now is highlighted. This is the Scratch Cat's program. If I say move 10 steps, it's talking about the Scratch Cat. If I click the bananas, it is blank. I didn't put anything in this program yet. I can put move 10 steps here as well, and now it moves the bananas in its current direction. Okay, that's the idea. You can right-click to delete or just drag it back if you want to get rid of all that. But our goal is going to be writing a program for both the bananas and the Scratch Cat, because we kind of want to have the Scratch Cat walk over here and then walk away with the bananas. That's going to be our program. Okay, that's the goal. So let's come up with an algorithm to make that happen. So we would like to start the bananas out in the fridge, right? They're over here, so the Scratch Cat can come and grab them. And then we want to have the bananas stick around in the fridge for a little while, so that when the Scratch Cat walks over, they're still there. And then we want to have the Scratch Cat walk away with those bananas. So there will be some waiting involved for the bananas program. And then we're going to want to move the banana to the same place as the Scratch Cat at the same time, so it looks like the Scratch Cat is walking away with those bananas. Okay, so that's kind of the algorithm, and the way that you can get at that is, let's have our program that actually starts when the green flag gets clicked, of course. Go back up to motion. There is a very, very nice thing called glide. Glide, take 1 second while you're gliding to go somewhere random, or take 1 second to go to a certain XY coordinate. Isn't that beautiful? So I'd like the Scratch Cat to end up next to the bananas, and look what happens when I start dragging him around and his coordinates change. The glide block changes too. That sets it to its current coordinates. So if I want the Scratch Cat to end up right here, I'll just put him there, and now the glide block has that exact coordinate. Isn't that cool? So now I'll put him back over here, and when I run the program, he's going to go, take 1 second to get there, to that particular coordinate, XY coordinate. Okay, so take 2 seconds, please, to get there. When I click the green flag, it's like he's walking over. Does that make sense? Are there any questions about that? Let's see here. Yeah, so that's kind of what we want to have happen. The scratch cat, we want them to take 2 seconds to get there to the bananas, and then we want the bananas to like walk over with the scratch cat and end up over here. So we want them to glide to right there. So I'll drag it out now. That's the new coordinate for the bananas tab. And right now I'm in the bananas program, right? Just for them. When the green flag gets clicked, also do that. Okay. So now I have 2 programs. One for the scratch cat. Take 2 seconds to move over here. And then I guess we want him to move right back, right? Move back to the fridge or away from the fridge. So we'll have him glide right back. Maybe he can take 2 seconds to glide there. And then I want the bananas to take 2 seconds to glide to over here where the scratch cat is, which was around those coordinates, 163, negative 92. Okay, so watch what happens when I click the green flag. There's 2 programs that are going to run, this one for the scratch cat and this one for the bananas. There's something wrong right now, right? So the scratch cat will walk over, wait after 2 seconds, and then walk away. But look what happened. The bananas glided without the scratch cat at all, because when the program started, they just immediately started gliding, right? Does that make sense? So we should have them wait. Wait in the fridge, because it's going to take 2 seconds for the scratch cat to get over there. See that? It's going to take him 2 seconds to get to the fridge. Okay, let's put the bananas back. There's a wait block. It's I think it's in looks. No, it's somewhere. Oh, it's in control, thank you. Way down here. Wait 1 second. So I'll put it in between. Wait 2 seconds. Because that's how long. I'll add a comment to remind myself why I'm doing this. Wait 2 seconds for the scratch cat to actually get to the fridge. Okay? So now the bananas program kind of makes sense, right? So the scratch cat will take 2 seconds to get there, over here, and then he'll glide back to where he was coming from. And then the bananas wait 2 seconds for the scratch cat to get there. Then they'll glide away, taking 2 seconds, just as much time as the scratch cat was taking to get over there too. And so it looks like they're walking with him, or he's grabbing them and he's walking with them. Okay? Wait 2 seconds. And there they go with the scratch cat. Isn't that beautiful? Yay. So, there is a problem right now. Can anybody tell me, does anybody notice it? What would happen if I click the green flag right now? Would the program work as normal? Yes.
No, because the scratch cat's position is already at the banana. There's no block to reset the scratch cat's position.
That is, yeah, that's close to being right. If I run it, the scratch cat's doing fine. He goes back to where he started at the end of that program, so that's okay. But the bananas that aren't starting out in the fridge anymore, right? Does that make sense? So the bananas are in the wrong spot. We want them to always begin their life over here in the fridge. That's called initialization. We'll get into that in a second. But if I want at the start of the program the bananas to always be in the fridge, I better put them there. So it's like go to a certain coordinate. Just start out there. Just immediately go there. That's what the go to block does. So I'd like them to go to that spot. Does that make sense? And technically, if you stop the program halfway through, like the scratch cat will also end up in the wrong spot. So it's a good idea to start him where you want him to. Okay? So like, Mr. Scratch Cat, please start. Like always go to here when you start your life. Okay? Does that idea make sense? Just so that when you rerun the program, he's in the right spot. So go to, make sure you're there, walk away with the bananas, we're good. And now when I start the program again, the bananas are going to go to that coordinate that was in the fridge. Boop. The scratch cat will walk with them, wait 2 seconds, the bananas will start moving with the scratch cat. Okay? There they go. Bananas, they can go in the proper order. They can be in front. Alright? So that's my program. One for the scratch cat, one for the bananas. Scratch cat just starts out in a certain spot, glides over the fridge, glides back. The bananas make sure to start out in the fridge, wait 2 seconds for the scratch cat to get to the fridge, and then glide away with him to that same location. So that's our first more complicated program. Are there any questions about what I've been doing there? Does that make enough sense? All right, so I'm going to save that so you can have it too. I'll give this to you. the code from class link once I upload it all. Let's see what else. Yeah, I have a fun example. Next, I think that is my last main example. So if we're good with this, I have one last more complicated example. Let us make an alien abduction program. Let's have the Scratch Cat get abducted by aliens and then like disappear into a spaceship, and the spaceship flies off. Okay, so that will be my last fun example. Okay, so let's set the scene for that. I did save this, right? Yeah. File new. So the Scratch Cat is the star. He's gonna get abducted. There should be a nice like cornfield backdrop. That's pretty funny. It's like farmland kind of thing. There's a hayfield. Yeah, so here's where the Scratch Cat will get abducted. We'll put him there. And then we're going to need an alien rocket ship. You can technically draw your own sprite if you want to. Like you can paint your own alien ship, but I'd rather just use something that's already here to make it easier on me. I'll have you try this in a second, but I think I'll just use like a rocket ship. Let's pretend the alien stole a rocket ship. Okay. So that's the idea. Kind of the goal. Here's my little algorithm. This is the UFO. It's gonna like come down ever so slightly, send out a beam. The Scratch Cat gets beamed up. The Scratch Cat disappears into the rocket ship, right? So we're gonna hide him to pretend he's been beamed up completely into the rocket ship. There's gonna be showing and hiding going on, and then the rocket ship is going to blast off and hide itself as well, because then it's gone into warp mode and it's off into outer space. Okay, so that's kind of the game plan. So there will be some animations, there will be some showing and hiding, and everything has to happen in a certain order. There also needs to be like a tractor beam coming out of this rocket ship. So let's draw our own tractor beam. You can go to choose a sprite and paint one. And so here is me drawing a tractor beam. I think, can I make it like transparent? I don't think I can, but I'll show you how to make it transparent later anyway. But I guess the default color is purple. Let's make a purple tractor beam. Boop, boop, boop. And then I'll fill that in with my fill color. So now I have a purple trapezoid, and that will be my little tractor beam. Isn't it cute? So there is a way to make this transparent, and I think that's what we want here. You can do that with I think it's the looks. There is a certain effect. We want to change, not the color effect. The color effect like manipulates the color of the thing, which is cute. Back to normal there. You want to change there's a ghost effect, and that's transparency. So let's change the ghost effect by 50 so that it becomes like half transparent. And that's our little tractor beam now. Okay? So if I just click it once, it'll stay with that transparency, I think, and I don't need to make that part of any program, I don't think. So that's just good to go. And so, I don't know, call this the beam. The sprite one is, of course, has a name, Scratch Cat. It's important to me. But, yeah, so there's a lot that needs to happen here. Let's make it happen. So, the UFO needs to appear, move closer to the ground, send out its beam, the cat glides, the beam disappears with the cat, the UFO flies away. So I need to start everything off in the right spot. And so the fancy term for that in computer science is initialization. I need to initialize all of these things by giving it a starting value. That's what it means to initialize it, like give it an initial thing to start out with. Okay, so we initialized the bananas, for example, in the last program. We'd like to initialize the rocket ship to start out hidden, for example. We'd like to initialize the beam to also start out hidden because the rocket ship is not ready to beam up the cat because it's not shown yet, right? So there's a lot of stuff that needs to go on here. So when the green flag gets clicked for the rocket ship, for example, let's go to its program. When that green flag gets clicked, that rocket ship better not be visible. So let's go to looks, and I have a feeling there is a hide block. So hide will hide the rocket ship. So at the beginning of the program, rocket ship, please start out hidden. Okay. Same with the beam. at the beginning of this program, when the green flag gets clicked for the beam, started out hidden as well, because the rocket ship is not there, right? It's also hidden. Does that make sense? So I'll click it now just so that it starts out as I want it to start out. And then the Scratch Cat's cool in his spot, but he's going to eventually be beamed up. So let's initialize the Scratch Cat to be like right here in the hayfield always when the program starts. So when the green flag gets clicked, make sure the Scratch Cat is right there. So like go to that particular coordinate. Okay, so because if he's not there, going there will just morph him right there. So immediately place him there where he needs to go. And he should start out shown because he's eventually going to be beamed up into the spaceship. But I'm going to forget that. I'll eventually come back to it. All right. All right. So that's fine. So the very first thing that happens in this program, right, is the rocket ship appears. Right. The rocket ship appears, and it better start out like. Let's see. Actually, I think I got it backwards. The rocket ship should be the first thing to appear. So maybe I should show it at the beginning of the program. But it needs to be shown up here because it's eventually going to glide down and glide back off. So let's initialize the rocket ship to be up here. So let's go to rocket ship. Make sure you're up there before you show yourself. Start them out hidden. Why not? So go to there, show yourself. And then we want the rocket ship to like glide down. So let me show the rocket ship so that I can actually show you what needs to happen. We want the rocket ship to glide down so it looks like it's like slowly landing on the hayfield or slightly above the cat, right? So let's have it take its sweet time to get to that particular position. Take 2 seconds to get to that spot, but make sure to start out up here, of course. So glide down, and then we'll send out its tractor beam. Okay. So here's what happens right now with the rocket ship. It's like starting out up here, slowly gliding down to the cat. Does that make sense? So it's starting out up here, initialize, making sure it's shown, and then gliding down to close to the Scratch Cat. Okay? We good with that? Again, just yell at me if it's not making sense. It's just a bunch of stuff in order. We have to remember that sequentiality to everything. So glide down to that spot, and then the next step, at least as far as the animation is concerned, that's when the beam should show itself, right? The beam is starting out hidden. We need to show that beam once the rocket is in place, in position. So show that beam. But now my question to you is, when should the beam be shown? It's not at the beginning, right? Because the rocket ship is not in place. How long should the beam wait before it shows itself? When is the rocket ship, after the green flag gets clicked, in the right spot? 2 seconds. That's exactly how long it takes. The rest of these blocks, like go to and show, those happen immediately. There's no time it takes for those to run. This one's taken 2 seconds. And so that's how long the beam should wait before it shows itself. 2 seconds later, it's in the right spot. So wait, please, Mr. Beam. 2 seconds, it's in control before you show yourself. So stay hidden for 2 seconds. Keep the beam hidden for 2 seconds while the rocket ship is moving into place. And that's the idea. And so this should work out. Boop, boop. And there it goes. It shows itself. I guess maybe I also want to always change its ghost effect. Sure. Keep it transparent. Make sure it's transparent before it shows itself. And that's a good spot for it. Whee! So that's the beam. So the rocket ship takes 2 seconds. Make sure to start out, initialize it, initialize the rocket ship. Here I am, initialize the rocket ship's starting location at -133 apparently is the right spot. Take 2 seconds to glide down after you show yourself. All right. And then the beam over here in its program starts out hidden, waits 2 seconds before it makes sure to make itself transparent and then show itself. Okay? Do we see how those two programs are working together? And it's all going as planned. Okay? Are there any questions about that? Because then, what needs to happen next? Well, the Scratch Cat needs to be beamed up, right? Beam up the Scratch Cat, please. to like pretend that he's like close to the rocket ship. But now my question is, how long, right? How long should we wait before the Scratch Cat starts getting beamed up? Because the rocket ship is going to take some time to get into place, right? How long should the Scratch Cat wait now before it gets beamed up? What's the secret number?
3 seconds.
Why 3?
1 second delay.
Oh, that could work. Yeah, 3 could work. 2 is also correct, right? It could also be 2 because that's when the beam shows itself. So when the beam turns itself on, that's 2 seconds later, right? 2 seconds later. Everything that doesn't have the word seconds in it, those blocks get run immediately. They happen immediately without any delay. So I think, yeah, either one works. Let's do, I'll do 2 seconds. You can change it later to 3. That will also be fine. So I'll have the Scratch Cat wait for 2 seconds for the beam to get into place. Because that's how long it takes for it to show itself. The rocket ship goes down, takes 2 seconds. The beam shows itself after 2 seconds. So wait for the beam to show itself after 2 seconds after we click the green flag, right? And after that happens, the Scratch Cat needs to get beamed up. So he needs to glide, right, closer to the rocket ship. So glide 2 seconds to some location, and it's not that one. Let me get him out of the way. Glide 2 seconds to be like right there or something. I don't know. Glide 2 seconds, Mr. Scratch Cat, to there. Boop, and I'll move this comment up here. Let's put the beam back where it belongs. And so now the Scratch Cat is making sure to start out here, waiting 2 seconds, because that's when the beam takes control, and then he glides up into the beam, into the rocket ship. Okay? Does that make sense? And then after he's been beamed up, he should hide himself, right? Because he's been beamed into the rocket ship. So after he's glided, we should hide the Scratch Cat. Boop. There he goes. And now he's in the rocket ship, and so we're almost done. If I click the green flag right now, what's wrong with the Scratch Cat's program?
The beam is still there and the rocket ship is disappearing.
Oh no, that's all fine. It's all gonna make sure to start out in the right spot, the beam and the rocket ship. The beam will hide itself the second I click the green flag. That's all okay. What's wrong with the Scratch Cat's program specifically when I click the green flag? Will it run as normal? So I think something's a bit off. Do we see it? Yeah. Scratch Cat is hidden. I'm not re-showing that Scratch Cat, am I? So, I mean, he's doing all the right stuff. We just can't see it because at the end of the program, he gets hidden. So if you want him to start out visible, you better initialize him to be visible. Do you see that? That's important. So now when I click the green flag, he's making sure to show himself in his spot. All right? And so that is very close to a correct program. The rest of what I want to do is have the beam disappear, now that the Scratch Cat's also disappeared, and then have the rocket ship fly off and itself disappear. Okay, so there's a lot going on there, but that is the end. That's my game plan. Okay. So now the question is, how long should the beam wait before it hides itself? Should I hide it immediately after it shows itself? Because then it'll just flicker. We won't see it at all. So, yeah, we need to wait a little while for the beam to go away. And I guess, what's the waiting period? I heard 4 seconds. Are there any other thoughts?
It's actually 2 seconds.
Yeah, it's 2 seconds. Because that's how long it takes for the Scratch Cat to make use of that beam. Do we see that? That's how long he's gliding for. So the beam is shown. Scratch Cat takes 2 seconds to glide up into the rocket ship. There he is, gliding 2 seconds. So that's how long it should take for the beam to stay put, right? It should show itself for 2 seconds, which involves showing first, then waiting 2 seconds, and then it can hide itself. So now stay visible for 2 seconds while the Scratch Cat is getting beamed up. And that's the right amount of time for that beam. So this is the beams program. So it starts out hidden, waits 2 seconds for the rocket to get into place, shows itself, waits 2 seconds for the scratch cat to get beamed up, and then it hides itself. Okay? So do we see how like the order of all these operations is very important? It's all happening sequentially, and we had to come up with the right special numbers and everything like that. Okay? And so I've got 3 separate programs going on right now. One for the scratch cat, the rocket ship, and the beam. The very final piece of the puzzle is the rocket ship needs to fly off now and disappear. My last question involving time is now. So, all right, the rocket ship needs to stay put right there for how long before it glides off? It's 2 seconds again, yeah, because that's how long it took for the scratch cat to get beamed up. He's gliding up for 2 seconds, and that's when the beam hides itself after those 2 seconds. That's when the rocket ship has its cargo, right? It's ready to fly off and abduct the cat. So it's a 2-second waiting period. Good. So this is the rocket ship's program. Stay put for 2 seconds while the cat is getting abducted. All right, and then it can fly off. I guess I want him to fly off back to where he came from, up there maybe. So motion, please glide to, take 2 seconds to do that. Glide 2 seconds to up there. All right, oops, let me stop the program. So here's the program now. I'm focusing on the rocket ship now. Waiting those 2 seconds, and now he's off, and he's up, and let's pretend he goes into hyperdrive right then and there. And so the very last thing we want to do to the rocket ship is have it disappear. Okay? Looks. Hide. And so definitely go back and study this program. I'm going to force you to do that in just a second as well. But this is a good one to study after class. All right, so here's the rocket ship's program finally complete. So he starts out at the top of the screen, shows itself, glides down to where the scratch cat is, because the scratch cat will be visible at that point. Wait 2 seconds for the scratch cat to be beamed up, because that's what's going on in the other programs, right? And then glide off into the upper atmosphere and go into warp mode and disappear. Whee! Blast off and into space. So that's the rocket ship's program. I think I just explained it, right? Let me walk through the scratch cat's program. The scratch cat at the very beginning makes sure to show himself down here in the hayfield. He's going to wait 2 seconds for the rocket ship to get into place and the beam to display itself. And then he'll glide for 2 seconds up into the rocket ship that's now in place. And then he will have been beamed up at that point. He can hide himself to pretend that he's in the rocket ship. Up he goes, and then he hides himself. Okay, and the rocket ship flies off and does its thing. We good with the scratch cat's program too? All right, last is the beam's program. So when the green flag gets clicked, the beam's not ready to be displayed because the rocket ship isn't in place. So we have to wait 2 seconds for the rocket ship to get into place. We'll make sure that the beam is transparent with this ghost effect thing. And then the beam is ready to show itself. Once the rocket ship has taken 2 seconds to get into place, we wait then 2 seconds, keep that beam visible. That's what it means to wait after showing yourself. Keep yourself visible for 2 seconds so that the cat can be beamed up. And then you've done your job as a beam. At that point, you can hide yourself, and then the rocket ship is ready to glide off. Okay? So does the beams program make sense? All 3 of them are working in tandem to create this cute animation. Okay? So that's the idea. I will save it. Are there any questions about any particular program, them all together? Does it make enough sense? Yeah.
So if we actually hide the beam at the end of the program, do we have to hide it in the first place?
Technically, no, if you allow the program to continue to completion. You're able to stop the program halfway through with this stop sign here. If I do that, now the beam is visible. So if you want everything to initialize itself properly, it's a good idea to hide it. Get it exactly how you want it at the beginning, just in case the user stops it in the middle when it's still visible. Good question. Any other questions? All right, did I already save it? No. So let me save this. There we go. And so now I'm going to give you guys some time. Make sure you've signed in for attendance because I'm going to stop that after I give you your time to work on this thing. So make sure you're there so that you don't get dropped. And yeah, and then I'll come around and help anybody who is having trouble signing in for attendance. Yeah, I'll tell you in just a second. So everybody else, I would like you to recreate this example. I'll give it to you on Discord if you want to just cheat and you haven't been following along. I'll give you the file that you can load. And I'd like you to recreate this example and change it up a bit. Here's one example. One idea is let the Scratch Cat get away safely. Have him run away to the side and shout obscenities at the rocket ship or something. You can do all that in your program, right? So let me give you my code if you want that as a starting point. But if you were following along, you can just go from there. So change up the code, have it play out differently. All right, so that was this one. Let me drag it into our CSCI1 channel on Discord if you want it. There it is. I believe it is now uploaded. Cool. So you can download it from there if you want. Otherwise, I'll keep part of it up and I can switch between pieces if you're wondering about something. So yeah, take a few minutes, like 5 minutes, to help each other, help your peers who are next to you, introduce yourselves, and make something cool. And then I'll help everybody get attendance done. Attendance is on our class website. Did you see that link on our canvas? It's www. It's on our campus homepage, but you can also just type in. See at the very bottom there. And then your username is your last name underscore your student ID all lowercase, and your password is the same right now. Your password is exactly the same as your username right now, and you can change that once you log in if you want. But that's your account. I'll show you where to go. Beautiful. So you will go to take attendance, and you can click any button, whatever you want, just to say that you're here, and then you can confirm that you were marked here to go back to the home page and view my attendance after. I have to complete it. I have to stop the attendance. Once I click that button, it should say that you're here. Okay. Anybody else having trouble with attendance? The last name underscore all lowercase. Same as your username. All right, so I'm about to stop attendance. Yell at me right now if you have not signed in. All right, end attendance. So now you can go to the View My Attendance button and confirm that you're marked here. All right, if you feel like it. Let's see. All right. So yeah, take a couple more minutes to play around, and then I'll talk to you about your first program. The rocket should do that is what I did. Yeah, let me play it for you. I have the rocket ship lined up after it's finished. And so here's my rocket ship program, and here's how it's doing its thing. All right. So there will be plenty of time to keep playing with this, but let me bring your attention right back here for just a second. The last thing for today is I want to release your first programming assignment, and then you'll have the rest of your time to work on it if you want. Okay? So let me go to the first programming assignment. It will be programming assignment 0, because in computer science, we don't number things starting at 1, we number things starting at 0. So, dun dun dun. So we do week 3, which is apparently January 26th. We are in week 1, right? So we do the Thursday. So 2 weeks and a day from now. That's usually when I'll have programming assignments due on Thursdays. Just like essays will be due on Tuesdays. So here is your first assignment. So I have 2 different assignments depending on if you have programmed before or you have not programmed before. Okay? So one if you're new to programming, another if you've programmed before. So you're going to do the one that applies to you. I don't want you getting 100% super easily if you've programmed before. That's not fair. I want to make sure everybody does the same amount of work. Okay? So if you are brand new to programming, which a lot of us were in this class, we checked that box, right? You will do an assignment on this Hour of Code website. You'll click this link, go to hourofcode.com, and you will click any of these. So whichever one looks the coolest to you, like you can make games, You can make animations. They're all fancy. Do whatever floats your boat, catches your eye, and after you finish, it should give you like either like a little virtual letter of completion, or just like it shows you like you were on the last lesson and you completed that with a check mark or something. What I'd like you to do to just prove to me that you completed the assignment is to give me a screenshot of whatever that final thing is, like your certificate of completion or whatever, and then I'll give you points for that. Okay? I'd like to also see your code if possible. So upload just like a screenshot. That will be how you submit proof that you completed this hour of code assignment. And so that's for my students who are brand new to programming. Okay? It'll be a very close to Scratch-like thing, if not exactly Scratch. Program that you'll be writing. If you have programmed before, I would like to force you to learn a new language. It's called Racket. And here is a textbook that teaches you Racket. You can you just click it to look at the book. So those of you who have programmed before, you're going to do this assignment, not the one above. All right. So I would like you to read chapters 1.1 and 1.2 of this book called How to Design Programs. It's in part 1. And here is 1.1 and 1.2. Just read through them. It teaches you a language called Racket, which looks really weird compared to what you know before, what you've seen before. It's just a bunch of parentheses and spaces in between, and that's pretty much every piece of the language is just a bunch of parentheses all over the place. It's really cool, very powerful. It was one of the first programming languages. It's based on one of the first programming languages called Lisp, but the programming language itself is called Racket. You will install the Racket programming language on your computer, and I want you to do exercise 2 out of the book. Okay, I think that's in chapter 1.2 or something. So just upload a screenshot of you getting the right answer for exercise 2, and that is you completing the assignment. Okay, so that is my assignment for those of you who have programmed before. If you've programmed before and you would like to do something other than this, like this, learning a new language is, I'm actually going to force you to learn a new language no matter what. But if you don't like this one for some reason, contact me and I'll give you we can come up with a custom assignment for you that is a reasonable amount of work and that interests you. Okay? But yeah, that's how it works. So people who have never programmed before, do this one or talk to me. Okay? Any questions about that? Yes. Yeah. Just search for it. Install Racket. I think Google will take you there. And in theory, this book should have a link to it as well, since it's teaching it. Yeah, it's just you'll be working in a programming environment called Dr. Racket. It'll be cute. So yeah, that's your first programming assignment. Any other questions about that? Yes. I'm sure there's an extension for that. Yeah. Yeah, it's totally fine. Wherever you want to work on it is just fine. Some of the assignments, though, later will start having you do animation, and that only is possible within the Dr. Racket program. So you'll have to go there, but you can do the coding, at least, in Visual Studio Code if you want. Yeah, good question. Any other questions? So yeah, that is your first programming assignment. It is out, just like your first essay. I will stop the recording now.